Okay, so today we're going to look at calculating the area of a sector, and a sector is a slice of a larger circle. So the learning intention is the skill and process of calculating the area of a sector. So to be successful, we need to be able to recall the formula for the area of a sector and correctly calculate the area of a sector. So remember that the area of a circle is the formula of pi r squared. So if we want an area of a sector, and let's say we're using degrees, we would have the degrees over 360 pi r squared. But now we're going to be using some radians. So let's say we have this sector of A, and that's a fraction of the full area of the circle. Now, the angle is a fraction of a full revolution. And the full revolution in radians of 360 is 2 pi. Okay, so if we were to then obviously cross multiply, so let's say a 2 pi equals theta pi r squared, obviously divide by pi, so we'll just say 2 lots of the area is theta r squared, and now divide by 2, the area is a half of theta r2, radius 2. Yeah, where theta, in this sense, is in radians. Okay, so the area of a sector, if we're doing degrees, is 3 pi over 360 pi r squared, with theta, that's in degrees, and if it's radians, half of r squared theta. So find the exact area of the sector whose radius is 5 centimeters and whose subtended angle, remember subtended is the angle that's created by joining 2 points. So this is 5 pi on 6. The radius is 5 centimeters. So we're in radians. We're going to use the formula. A equals a half of so 5 squared times 5 pi on 6. So that's basically 25. So a half times 25 over 1 times 5 pi over 6. So 5 lots of 25 is 125 pi over 12. Can we simplify that? Yeah, so, and that's all we can do. So we're in centimeters, so it's area centimeters squared. Okay. We want to find the area of the sector of a circle with a radius of 4.3 and an angle of 1.8. So 4.3, 1.8. Okay, so and that's 1.8 radians. So we're going to do a half r squared theta, a half times 4.3 squared times 1.8 radians. Use a calculator, 0.5 times 4.3 squared times 1.8. We get 16. And we're in centimeters. squared, 16.641 meters squared. So we want to calculate in terms of pi, the area of the shaded region. Okay, so firstly, that 45, converting 45 degrees into radians, so you do, is the same, is going to be pi on 4. So you could do that as 45 times pi over 180. So we did 45 times pi over 180. 45 over 180 equals 1 over 4, which means pi on 4. Okay, so we're going to basically calculate the area of the larger circle, of the larger sector, and then we're going to minus the area of this smaller sector. So the larger sector is going to be a half r squared theta, and theta is in radians. So the larger circle is the sector is 25 squared, and it's going to be pi over 4. So a half times 25 over 1 times 1 over 4 is 25 pi over 8. And the smaller sector using the same formula, now the radius is 10, still pi on 4. Sorry, that's 25 squared, so that's 625 pi over 8. This is 25 pi over 2. So if I'm going to subtract, I've got so area of the shaded bit is 625 pi over 8 minus 25 pi over 2. So 625 pi over 8, multiply that by 4, so that gives me 100. Subtract the numerators together, so the total area is 525 pi over 8, and we're in centimeters. Okay. All right. The area of a sector AOB of a circle. Okay. If center 0 is a radius of 20 centimeters, so the area is 240 centimeters squared. Okay, yeah, squared in center. All right. We want to find the size of this angle. Well, if we use the formula of A equals r squared theta, we know that the area is 240. We know that the radius is 20, but we don't know what theta is. So using our algebra, 20 squared times 0.5 gives us 200. So theta has to be 240 over 200. which is 6.5 or 1.2 radians. Now they want to, the second question is calculate the arc length of AB. So the arc length is r theta, which is theta being radians. So the length is the radius times by 1.2 radians gives us 24 centimeters. Okay, and that's it. All right, thank you.